If you've ever wondered how today's most advanced AI systems, like ChatGPT, BERT, or Google Translate, can understand your questions, generate coherent answers, or even write code, the answer lies in a groundbreaking architecture called the transformer. First introduced in a 2017 research paper titled, "Attention is All You Need," the transformer fundamentally reshaped how machines process sequential information like language, time series, and code. Before transformers, AI models often relied on older architectures like RNNs or CNNs, which processed data in order and struggled to remember distant information in a sentence or paragraph. The magic of transformers lies in how they rethink this entire process. Instead of moving step by step through a sequence, they look at the entire context all at once, weighing the importance of every word or element in relation to every other. This technique is called self-attention, and it allows the model to recognize patterns, relationships, and meaning, no matter where things appear in the sequence. Think of it this way: when a human reads a sentence, we don't just go word by word, we instinctively jump back and forth, using the full sentence to understand meaning. A transformer does something similar, but mathematically and at scale. Here's how it works at a high level. 1. Self-attention lets the model evaluate the relationship between each word and every other word in a sentence. This means it understands context, whether a bank is a financial institution or a riverbank. 2. Multi-head attention takes this a step further by letting the model look at different kinds of relationships simultaneously: syntax, meaning, structure. 3. Positional encoding adds information about word order, so the model knows what came first and what followed. 4. These mechanisms are stacked in deep layers, forming the encoder, to understand inputs, and the decoder, to generate outputs. The result? A model that doesn't just memorize, it comprehends. It reads legal contracts and summarizes them in plain English. It understands a customer email and instantly classifies it. It can even write a recommendation or generate a report based on your input. In the context of large data models, the transformer is revolutionary for one simple reason: it scales effortlessly. It handles huge datasets, long documents, complex relationships, and it can do it fast, thanks to its ability to process data in parallel. This is why companies like OpenAI, Google, and Meta build their most powerful AI models using this architecture. Let's look at a practical use case in insurance. Imagine an AI system that reads through thousands of claim reports every day. A transformer-based model can understand the narrative in each claim, detect subtle patterns that may signal fraud, autofill structured data fields from free text descriptions, generate personalized follow-up messages for customers. All of this happens not because the model was hard-coded with insurance rules, but because it learned patterns from vast amounts of historical data. That's the power of transformers: general intelligence across domains, built on pattern recognition and context understanding. In summary, if large-scale AI were a symphony orchestra, the transformer would be its conductor, coordinating and interpreting every note, phrase, and pattern to produce something intelligent, elegant, and powerful.